Assalamualaikum and a very good morning to the organizer, judges, teachers and fellow friends. Today, I'm Nurhani from Wales with my fellow members, Danish Lian and Mohammad Badisham will present our finding of our research entitled Clean Water. The COVID-19 pandemic has demonstrated the critical importance of sanitation, hygiene and adequate access to clean water for preventing and containing disease. Hand hygiene saves lives. According to the World Health Organization, hand washing is one of the most effective actions to reduce the spread of pathogens and prevent infection, including the COVID-19 virus. Fortunately, billions of people, mostly in rural areas, still lack these basic services and funding is inadequate. It is hoped that our low-cost innovation helps to lessen the water crisis and supporting the SDG 6, one of the 17 SDGs adopted by the United Nations. Have you all wondered what are the problem statements that we get from our research? Then let me tell you, the worldwide, the water and sanitation crisis is getting worse. The challenges are unprecedented and growing. Hence, there is a need for an immediate and integrated global response to rapidly improve progress on SDG 6 to ensure availability and sustainable management of water and sanitation for all by 2030. It is reported by United Nations that, firstly, between 1990 and 2015, the proportion of the global population using an improved drinking water source has increased from 76% to 90%. Secondly, more than 80% of wastewater resulting from human activities is discharged into rivers or sea without any pollution removal. And lastly, by 2030, 1.6 million people will lack safely managed drinking water. Next, we move to the experimental research done for this project. Analysis 10 samples of water collected from the various places to determine the level of water pollution in the samples. By these samples, the level of water pollution can be determined by measuring the time taken for methylene blue solution to decolorize after being mixed with water sample.
The data, when methylene blue solution is added to a contaminated water sample with a low concentration of dissolved oxygen, the blue color of solution will decolorize rapidly. These experiments are done for the duration of 4 hours and observation as in the table. For the discussion, biochemical oxygen demand BOD is the amount of dissolved oxygen needed by microorganisms such as bacteria to decompose. Organic substances in a water resources, the higher the BOD, a water sample, the more microorganisms can be found in it. So we come out with a solution for the problem through a filtering process using rock layers and some selected filtering materials. The innovation brought by is using the least cost and recycled materials. By using the first and second water filter, the filter was found to still contain suspended particles, cloudy and smelly. The third water filter was being modified by adding lumps of charcoal and a mixture of wood and bamboo fibers and removing fine sand. In order to obtain water that is safe to drink, the filter is being boiled to collect water vapor. Water vapor then undergoes a condensation process to obtain water that is safe to drink and free from salty taste and unpleasant smell.
In conclusion, the 2030 Agenda for Sustainable Development recognizes many challenges that are closely related to water resources and water-related ecosystems across the world. Hence, it is everybody's role to solve this crisis, and many of the solutions from around the world prove that dramatic gains in water is possible, and some are inexpensive, effective, and can be quickly deployed. Therefore, our innovation can become a small part of the solutions to support the notion of SDG 6 by focusing on the quality of water and increases the availability of water resources such as from ocean. They are therefore essential for achieving sustainable development, peace and security, as well as human health and well-being.